Alright, I just purchased one of these microinverters from Link Solar. So it's kind of a cool new microinverter and it's pretty affordably priced, so I wanted to test it out. It comes with this MC style cable, and it has 3 terminals, and this is a 120 volt microinverter. So what I'm going to do is, to test it out, is I'm just going to try a plug and play type of scenario. So I just got here's one of these little 120 volt AC plugs that you can pick up at Lowe's. And if you read the manual, okay, you'll see that, if we can get to focus. Alright, so the first thing I noticed when I started to work on this Link Solar inverter project is that the colors for this this cable do not match the colors listed in the instructions, which is black, yellow, and red. So there's clearly some issues that need to be resolved, but hopefully the connector pinout is accurate. And what we'll do is match the terminals to the correct ends of the cable with the help of a voltmeter and continuity test. Alright, so with the help of a continuity tester, I was able to determine which colors will match up to the corresponding prongs on my electrical plug. And yeah, whenever you get some foreign made product that has kind of funny wiring instructions where the colors don't match, you just want to go back to the connector, look at the connector carefully, and just do a continuity test to determine the conductivity of everything. And so in this case I determined our neutral was actually green, which doesn't match the American standard at all. But neutral will be green. Our ground they have listed as yellow, but I determined it is our black wire that's going to the ground prong. And white is actually our line, our hot lead. And they said it should be red, but there's no red cable, so we're connecting the white line to the hot terminal of our plug. And if you don't know which terminal of your plug is which, let me switch it over. Switch over to AC volts here, and you should measure 120 volts. So you should measure 120 volts between the hot plug and the ground. And you should measure just a few millivolts between the neutral and the ground. So, neutral to ground, 150 millivolts AC. So that's how to test your outlet to make sure you have the correct prong orientation with your plug. Alright, so we're about to ready to plug in, and just go back and check this. Remember from our voltmeter test we determined that this was the hot of the electrical outlet. And just double check your wires. And actually I found that I had accidentally reversed my green and white wire, my neutral and my hot. So I went back and switched it. So the white line from our wiring illustration is the hot, and if we plug it in like this, we'll find that the white line is going into the outlet, where the hot slat of our outlet. So I'll just put on the safety cover before we plug it in, and then we'll test out our microinverter. Alright, I'm testing the Link Solar module here, and I have it hooked up to 200-watt solar panels. So 200 watts of solar, and I have it plugged in, and it's coming down to my kilowatt hour meter and registering between 60, and I had 120 watts here a second ago. The sun just went behind a cloud a little bit. Okay, the sun's out from behind the clouds here. And so we're measuring 124 watts of power out of our Link Solar microinverter. So just want to test the insulation with my pyranometer here. Around 950 watts per square meter. So it's almost STC. So our Link Solar module is putting out about half power. Let's try to look at this again. All right, full sunlight, 995 watts per square meter. Oh, touching on 1,000 watts per square meter. Roughly the test condition for these solar modules. And we're outputting 124 watts, 128. So we're a little underpowered with this this microinverter. And let's look again, just test again. So again, we're about 900 watts per square meter. We're hovering at about 130 watts of output from our Link Solar module, or solar microinverter. Alright, so this is another brand of the Link Solar grid tie inverter, 120 volts AC, and it puts out about the same amount of power as the other, 125, 130 watts. And let's just check it against our 200 watt solar panels. And we're about 850 watts per square meter. Still 125 watts output. So we should expect a little bit more power out of this unit. But that's all it's got. Still going at about 100 watts here with this little microinverter. And these two solar modules, just in case there's some question about what type of modules I'm using, are Solar Power Industry modules. Actually, they're 105 watt modules. They output 16.8 volts each. They have a short circuit current of 7 amps. And I have them connected in series, only 32 volts at 7 amps. just one last look here at our Link Solar microinverter module. So again, we have two 200 watt panels feeding it, and we've got pretty much the full 1,000 watt per meter square sunlight, and we're getting 125 watts out of it, which should probably be pretty close to 200. And the microinverter is sourcing 1.2 amps, 126 watts, 120 volts. Let's see, what's it? 49 VA. Alright. And I'll just disconnect solar power. And it goes to 0 watts. So it doesn't seem to draw any power when it's off, so that's good. And our little indicator light goes off as well. Alright, also testing out this Link Solar modem and the software for the solar panels. And the software seems about useless. It's checking for the solar collectors, and all these tests fail. And then you get an error message. And I've tried both microinverters and put the modem up as pretty much as close as possible to the microinverter power. And I've got the RS-232 to serial coming into the USB. And also there's a power light on the modem, and also the RxD light, which I think is transmission from the computer, is active, but I don't see any colors on this TXD, which I think this would be data from the microinverters, but I'm not sure. So inverters work, but half power. Then the modem and software doesn't seem to work at all.